Hi everyone, welcome to Technology. On today's session, I'll be walking you through Monolith application into microservices. Alright, let's go through this, guys. Alright, so what is Monolith application? Monolith application is a traditional software architecture style where the entire application is built as a single interconnected unit. In a monolith architecture, all the components and functionalities of the application are tightly integrated into a single code base, and they all run in one same process space. Monoliths are usually deployed as a single unit, and any changes to the application require redeploying the entire monolithic code base. Monolithic application is basically what they've been using in the past. That's why it takes a long time for them to be able to release application or to actually fix any issue. Monolith applications have been widely used and are suitable for many projects, especially smaller applications with simpler requirements. However, as applications grow longer and more complex, monolith architecture can become difficult to maintain, evolve, and scale. Changes in one part of the application may require extensive regression testing, and deployment can become more challenging. You know, as application evolve and demand for more flexibility and scalability increases, many organizations are moving towards microservices and other modern architecture styles that allow more modularity, flexibility, and independent deployment of components. These modern approaches aim to address the challenges of monolith architectures and provide more efficient way to build and scale larger complex applications. So basically, you can see how monolith application look like. You know, you got a browser, which is the Apache. That's what's gonna be visible to the users, and all the entire modules are compiled in one single tier application. You see, we got a notification, email, payment, location, everything is tied to this single application, and they are all using one database. That means if payment module got problem, they have to like lose everything to get to this payment, fix it. That means everything can pause, and they have to test everything back all over again by the time they fix whatever they want to fix. So this is kind of redundant. You don't want to keep breaking all the application to get into one module. So those are the way they used to deploy many applications back in the days. But due to the microservices, everything changes. All right, so let's go through characteristics of a monolithic application. Number one, unified code base. Like I said, a monolith application has a single code that contains all the modules and features of the application. The code base can become larger and complex over time. Two, tight coupling. Components and modules in a monolith application are tightly coupled, meaning that changes to one part of the application can affect the other part, of course. Single process. All the components of the application run with a single process, sharing the same memory and resources. That's dangerous. You know, Number four, shared database. Monolith applications typically use a single shared database for all their data storage needs. You know, Number five, monolithic deployment. The entire application is deployed as a single unit. When updates or changes are made, the whole application needs to be redeployed. That could cause delay. Then number six, scalability challenges. Scaling a monolith application can be challenging because all the components are interconnected. Horizontal scaling usually involve replicating the entire application on multiple servers. That's kind of ethic. Number seven, technology stack. Monolith application often use a single technology stack and programming language throughout the application. Basically we've been talking about waterfall and all that. This is the way they've all been following in the past. And due to microservices now, everything changes. All right, so let's go through what is microservices. All right, so what are microservices? Microservices are a modern architectural approach for designing and building software application as a collection of small, independent, and loosely coupled services. In a microservices architecture, an application is broken down in a set of small, independent services, each responsible for a specific business capability or functionality. These services communicate with each other over the well-defined APIs and can be developed, deployed, and scaled independently. That's smooth. That means you can work on each modules by themselves without disturbing every other functionalities. All right, so microservices architecture have gained popularity in the recent years due to their ability to address the challenges of traditional monolithic architecture. They allow for faster development, easier maintenance, and better scalability, making them suitable for large and complex application and distributed system. So now you see how microservices work. We build them separately and they all have their own database to themselves. You see, so we got notification separate, email. So now it looks more easy. If any of these modules have problem, all I need to do is to log in inside their container and fix them without affecting every other modules. They are still running. I'm just gonna like log in into this container, fix it, or probably detach it and replace it with another container. Very easy, you know. So microservices by Docker changes the whole game. All right, so let's go through key characteristics of microservices. Number one, modularity. Each microservice represents a single business capability or functionality, making it easy to understand, develop, and maintain. Microservices are designed to be small and focused, performing a specific task or service. Number two, independence. Each microservice is a separate and independent unit, allowing it to be developed, tested, and deployed independently of other services. The independence enable faster development cycles and the ability to use different technology stack for different services. So as you can see, this sounds quite easy. So number three, loose coupling. Microservices communicate with each other through over well-defined APIs, making them loosely coupled. This allows services to evolve and change independently without affecting other services. Then number four, scalability, which is certain for every business. Microservices can be scaled independently based on their specific demand, enabling efficient use of resources and better performance. Like I said, doing the monolith application is difficult because they are all combined and compressed together. But right now with microservices, you can scale, you can easily add more to your resources without affecting every other services. You see? So number five, resilience. If one microservice fails, it does not affect the entire application. The fault isolation provided by microservices makes the overall application more resilient. Then number six, continuous deployment. Microservices are well suited for continuous deployment and continuous integration practices, as each service can be updated and released independently. Number seven, polyglottism. Different microservices can be built using different programming languages and frameworks, allowing developer to choose the best technology for each services. You know, so number eight, DevOps friendly. Microservices encourage DevOps practices, as smaller services are easier to manage, test, and deploy, promoting collaboration between development and operation teams. So microservices is a DevOps tools. Everything changes when DevOps tool come to reality. All right, so like I said, this is microservices. You can deal with them separately. If one happen to default, you can actually go to it and fix it without disturbing every other services. All right, guys. So basically, this is what we mean by monolithic application and microservices. And this brings us to the end of this session, guys. And I hope you learn. Thank you.